All right, today we are solving equations involving square roots. So what we've learned in the past is when I have something squared, to get the x alone, we have to do the inverse operation, and that is root it. What I do to one side, I do to both sides of the equal sign. So we are going to root both sides of the equal sign. When I take the square root of x squared, we get not x, but rather the absolute value of x. Please remember that. And then when I take the root of 9, we get 3. To lose absolute value, we are left with plus or minus 3 is equal to that x. Now, on the other hand, when I square rad x, when I have rad x and I want to get x alone, I do the inverse, so that would be squaring. Okay? And when I square it, the root and the square negate each other. So we end up with x equals 81. So the one thing I want you to pay attention to is when we square over here, notice there's no absolute value. Versus when I root, that's when I end up with the absolute value. Is that clear? All right. So this is section 11.9. All right. So let's try, why don't you guys pause the recording and try number 1 and 2. Let's check our work. What would I do on number 1? Sarah?
You square both sides.
Square both sides of the equation, and we get?
Rad x squared equals 16 squared, and then I got x equals 284.
Not 284, 256. Okay. Next one, number 2. Let's go with Hannah.
Okay, so I got d equal.
What do I do?
First you square both sides.
Okay. And we get?
Y equals 49.
Good. Okay, so now what do you think we do with the next one? It's one step further. Andrew?
You would square both sides.
Good.
And then it'd be 2x equals to c4.
Good.
And then you divide 2 on both. Divide 2 on both sides. And that'd be 32.
X equals 32. Okay, what do you think we do first here in this next one? Yes, Sadie.
First I added 1 to the other side.
Okay, hold on. Why don't you pause it and you guys finish this one up? Hold on. Pause it. Do it again.
So first I added 1 to both sides.
We're adding 1 to both sides of the equation.
Then I squared both sides.
Then we're squaring both sides, and we get?
5x equals 225.
Good. And then?
You divide both sides by 5.
And we get?
X equals 45.
Perfect. So, not that difficult. Okay, next one. What do you think we do first? Eric?
You divide it by 2.
Divide both sides by 2. Okay. And we are left with the quantity of the radical x plus 3 equals 5. Next step, Leo. Square both sides. Jaden, what am I left with?
You're left with x plus 3 equals 25, and you subtract 3, and you get x equals 22.
And x equals 22. Okay, why don't you try number 6? It's putting it all together. Pause the recording and do number 6. All right, so now let's check our work. All right, are there any questions? Shh. All right, so now let's talk about domain. Okay, we're going to mix it up. We're going to mix it up. We've talked about domain in a couple chapters. I'm going to throw all kinds of questions in. So tell me, and in kid words, it means what is x allowed to be? But in math words, we say it differently. Okay, so what would the domain be of number 1? So we say that x can be an element of the reals. And how would I be more specific about that? I need a boundary, Frank.
And x is greater than 0.
X is greater than 0?
Greater than or equal.
Well, no, it can't be 0.
Absolutely, it can be 0. So, 0 is a perfect square. I can have a 0 under my radical. What I can't have is a negative. So we say X is greater than or equal to 0. Remember, that's a boundary line. Okay, how would I state the domain for number 2, please? Shh. Marcus.
So let me just check. Would it be x is an element of the reals? X is
And
X is greater than -5.
one more time. What sign do you need to use? Greater than or equal to -5. How do I get that? Set that little chunk under the radical greater than or equal to 0, because that's where my real numbers start. And yes, you were correct, but you never said greater than or equal to. I heard everybody else say it, but you. Okay, what about number 3? Shh. Greg.
X is an element of the reals, and X is any real number.
Any real number. We can just write any real number, right? Or X is an element of the reals. Okay, number 4. How might I state that? Santi.
Miss, X is an element of the reals, and X is greater than or equal to 3.
Yes. Now, if you don't know what that number is, take that 2x minus 6 and set it greater than or equal to the boundary. The boundary is 0. Right? Now what are we doing? Add 6, divide by 2. X is greater than or equal to 3. Questions? Okay. Tell me about the domain here. Janice.
X is an element of the reals, and X is greater than or equal to 0.
No, it's not greater than or equal to 0. Not for number 5. It's a fraction. These are new rules. Our domain is about what type of mathematical process we're doing. Now, before, we were dealing with radicals, okay, and a square. Now I have a fraction. One more time. State the domain. It's an element of the reals, and can it?
No.
What can it not be in fractions? Sydney.
It can't be a 0 because there's the, you shall not divide by 0.
In the denominator. So we show that with the math symbol, an equal sign with a slash through it. X cannot equal one number, 0. It can be negative. It can be positive. It cannot be 0. Okay, number 6. The domain, please. How about Lilith? No. Scott? Frank, sorry.
X is an element of the reals, and X is greater than or equal to 0.
X is an element of the real. Sorry, I don't know why I said Scott. Okay, so it's an element of the reals. If you don't know, Lilith, take the chunk out of the radical and always set it greater than or equal to 0. Then get your X alone. We get X is greater than or equal to 0. If you don't know, do the math. Okay, so X is an element of the reals and X is greater than or equal to 0. Next one, number 7, Lilith.
X cannot be 4.
Good. And? No. What number system is it part of? You got to say that. X is an element of the reals, and X cannot equal 4. Okay, next one. Jaden.
X is an element of the reals and X cannot equal
-8.
-8.
Good. No, it's not equal. You guys, there's 2 different domains we've talked about. In fractions and in radicals. In radicals, the rule is everything must be greater than or equal to 0. In fractions, you can't have a 0 in the denominator. So one more time, what do you say?
X is an element of the reals and X is greater than or equal to
-8, yes. Greater than or equal to, cannot be equal to. In this case, with radicals, it's going to be greater than or equal to. With fractions, it's just going to be can't equal. Is that clear? All right. Now, the thing with equations, with radicals, you absolutely must check, because both solutions do not always work. Because of the radical, because you have X on both sides, you get situations where it does not work. So, for instance, how might I go about solving this? Scott?
Subtract 9
I subtract 9.
and then try to square root it with the negative.
We square both sides.
Square both sides, then you get X is plus or minus 81.
Good.
Just 81.
Just 81. And now, here's the problem. As I substitute that back in, the square root of 81 is 9. 9 plus 9 does not equal 0. It will give you an untrue statement. So you have to check your answer. In that case, we say no solution. We don't say extraneous solution. It happens to be an extraneous solution, but we say no solution. It is a solution that works, but does not work for the context of the problem. Okay? Now, Scott, you were right to go with your instincts right here. That right there was the problem. You knew it, you saw it, but you've got to finish it out to the end. Okay? Where you're showing that it can't be that. Question, Jaden?
I'm just trying to figure it out.
What are you trying to figure out?
No, I think I understand.
Sarah?
So for these problems when it's like the square root of X equals something or plus 9 equals something, you don't put the absolute value ever? Is that
What okay, we don't put absolute value when we're squaring something. We put absolute value, we start to include the absolute value when I'm rooting something to both sides. Does that make sense?
Yeah.
We aren't rooting here, we're squaring to manipulate the equation. All right, so what do we need to do here? You guys want to try this one on your own? Pause it. And all right, so what do I need to do first? Sydney,
You would square both sides.
square both sides, and then I get
2x plus 3 equals x squared equals x squared. Oh.
x squared. Now what, Frank?
I subtracted 2x
And
and 3 from both sides.
subtract 2x and 3 from both sides. Shh. Hold on. Now I have something that people seem to be looking at like they've never seen it before. Like this is, hold on, this is for the recording. As if this were a new concept to us. Like we have not spent an entire semester dealing with something that starts with x squared. Maybe called a trinomial? So thank you. Shh. Thank you, Frank. Frank's talking.
So then you can do the X marks spot thing, and then it's 3 and 1, so then 0.
What is this process called that I'm doing? Everybody. We are factoring, yes. I know that you all are looking at it like it's brand new, but I swear to you, we have done this. As God is my witness, we have done this. Because we sat in here with, sorry, maybe I shouldn't be talking about that.
0 equals X minus 3 times X
minus 3 and positive 1. Okay, and what is it?
And it's the quantity of x minus 3 times the quantity
Shh.
of x plus 1 equals 0.
Okay, and then what are my solutions?
X equals 3 or negative 1.
Good. Now we have to check for our extraneous solutions. Let's start with negative 1. Does it work?
Yes.
So negative 2 plus 3 is what, Scott?
Oh, no, sorry.
That's the square root of 1. Is that equal to negative 1? No. So that's what we call extraneous. And does the 3 work? Scott?
It's 6 plus 3 is 9, and then square root of 9 is 3 plus 3 plus 3. So it works with 3, but not with negative.
So 3 is my solution. All right, now we're going to sage and scribe this last problem. This time the other person's going to be the scribe, and the other person's going to be the sage. Okay, go. Pause the recording and you do it. Scribes, we're going to check our work, make sure our sages and scribes. We should square it. Then we subtract everything to one side. When we factor it, we say that we did our x marks the spot. What multiplies to negative 20 adds to negative 1 is negative 5 and positive 4. And then, we get x equals negative 4 and or x equals 5. When we try them into the original equation, negative 4 does not work. It is extraneous, so it is not a solution. When I try 5, it works. All right. Now, there's a couple things that you're going to come up with in your homework tonight. So, like, you might have something like this. Okay, what would I do? Square both sides.
What if it was,
Hold on. Please don't interrupt me.
sorry.
And then I get x plus 1 equals 2x minus 5. Subtract it all to one side. And I get 6 equals x. Okay? Another situation. What if I have 3 rad x minus 1 equals radical 2x plus 5? Shh. What do you think I do? Yes.
Would you divide the 3 on both sides?
It's only going to take it to the other side. And I already have a radical there, so I can't get rid of it. So what do you think? What can I do to get rid of these radicals?
You square both sides.
Let's just square it. Now, when I square it, notice the 3 squares to 9, and then I'm left with x minus 1. Then it gets distributed in, and this is a 2x plus 5. So then I get 9x minus 9 equals 2x plus 5. Add 9, subtract 2x. I get 7x equals 14, divide by 7. X is equal to 2. All right, one more thing. With homework tonight, you're going to get some word problems. They are not hard. They are giving you a formula. They are telling you what to substitute in. Okay? They just include radicals. All right, that's the lesson for today.